All right, so if your business is all in on AWS, you are in the right place. We're going to talk about building a connection to the cloud that is, well, practically unbreakable. I mean, a high availability VPN that can take a punch and keep on going. Let's dive in.
So think about it. You've done the hard work, right? You've moved your apps, your data, your whole business is sitting up there in AWS. But have you ever stopped to think about that one single thread that holds it all together? You know, that connection from your office to the cloud.
Because let's be real, if that connection goes down, everything just stops, dead in the water. It's this huge critical vulnerability that, honestly, a lot of folks overlook. So today, we're going to change that. We are going to architect a connection that's built for resilience from the ground up, so you can stop worrying about that single point of failure.
Okay, so first things first. What's the actual challenge here? We're trying to build a solid, secure bridge between two totally different worlds, your physical office on one side and your virtual campus in the cloud on the other.
Yeah, so over here you've got your office with all your servers, your computers, your private network, and then way over there you've got your AWS VPC. That's basically your own private little neighborhood in the cloud. The goal is to get these two to talk to each other like they're right next door, even though they're miles apart.
So how do we actually build this bridge? Well, we're going to do it the right way. We're going to engineer it for high availability from the get-go. And what that really means is we're hunting down and getting rid of any single point of failure before it can ever become a problem. The tool for the job here is the AWS Site-to-Site VPN. The best way to think about it is like a private armored tunnel that you're building right through the middle of the public internet. Everything that goes through this tunnel is completely encrypted. It's a totally secure, private conversation between your office and the cloud.
Now, this is where the high availability magic really happens. We're not just building one of these tunnels, we're building two. See, AWS is smart. It automatically gives you two endpoints for every VPN. So you set up Tunnel A as your primary path and Tunnel B as its identical twin, a hot standby. If anything at all, happens to Tunnel A, traffic instantly and automatically fails over to Tunnel B. The result? Zero downtime.
Okay, so we've got two tunnels. That's great for redundancy. But how does the network know which one to use? And how does it adapt on the fly if something changes? Well, that's where we bring in the brains of the operation, a protocol called BGP.
BGP stands for Border Gateway Protocol, and it's basically the protocol that runs the entire internet for a reason. It's just incredibly robust. The best analogy is that it's like a GPS for your network traffic. Your router in the office and the AWS gateway are constantly talking to each other, sharing updates, and automatically telling each other about the best ways to get from point A to point B. It's totally dynamic. You set it up, and it just handles the rest.
And you know what's really cool? Setting this up is surprisingly straightforward. You really only need a handful of things. You need an ASN, think of it as a unique ID number for your network. You need the IP address of the AWS gateway you're talking to, and you need to tell it what your office network range is. That's pretty much it.
And that is the real beauty of using BGP. Your connection basically becomes self-healing. If one of those tunnels hiccups or fails, BGP sees it instantly and just reroutes all the traffic through the healthy one. No pagers going off, no frantic late-night calls. It just works.
All right, so we've built a connection that's reliable and it's smart. What's next? Let's make it fast. We're about to take that backup lane we built and turn it into another lane on a brand new superhighway.
See, out of the box, you typically get what's called an active-passive setup. All your traffic goes down Tunnel A, while Tunnel B just sits there, waiting, just in case. It works, it's reliable, but it's not very efficient, is it? The goal here is to switch to an active-active setup. This is where we tell BGP that both tunnels are equally good, and your router starts spreading the traffic across both of them at the same time.
And what's the payoff for doing this? It's huge. The bottom line is, running Active-Active literally doubles your throughput to the cloud. You're taking that single-lane country road and turning it into a two-lane highway. You get a much bigger pipe for all your data.
Okay, the architecture is solid. We've designed the perfect setup. Now let's get into the nitty-gritty. I want to give you some real pro tips here. How to double-check that everything is working just right, and how to avoid some of the common mistakes people make.
Verifying your setup is actually pretty simple. There are really only two commands you need to know. First, you check your IPsec tunnels. You're looking for the word up. That tells you the encrypted connection is live. Then you check your BGP status. You want to see the word established. That's your proof that the two sides are talking and sharing routes successfully.
And finally, let me give you 4 quick tips that will save you a world of headaches. First, watch out for the route limit. AWS has a hard limit of 100 prefixes you can advertise over the VPN. Don't go over it. Second, for that awesome active-active performance, you need to turn on a feature called ECMP, or Equal Cost Multipath. That's the magic setting that lets your router use both tunnels. Third, you'll want to enable something called TCP MSS clamping. It sounds complicated, but it just prevents big data packets from getting fragmented in the tunnel, which is a lifesaver for big file transfers. And last but not least, if you're connecting to more than one VPC, please use a transit gateway. It'll act as a central hub and keep your network clean and manageable.
So there you have it. You've built a connection that's redundant, it's intelligent, and it's fast. You've taken what was potentially a fragile single link and transformed it into a robust multi-lane highway to the cloud. The only question left is, now that your connection is built to last, what are you going to build next?